This exercise is a continuation of a multi-part exercise. Here we're given a transformation, unless I say otherwise it's a linear transformation, t from R3 to R3, given by the following formula. And we have two bases of R3, this and this. These appeared in a previous exercise. We have to find the matrix that represents the transformation in or relative to the basis B1, and then the same thing but for basis B2. And I want to remind you that as far as notation goes, that we write our vectors as row vectors for convenience, but really if you had the space for it, this would be the correct way to write this transformation, vertical column vectors. Okay, so we'll start with part 1. And here I just copied, here's the transformation and here's the basis that we need. From a previous exercise in this series of exercises, they're all part of a suite or a series, we got this result for the coordinate vector relative to basis B1. And now we have to do a computation for each of these three basis vectors. Let's start with the first, 1, 1, 0. We apply t to it, and using the formula x plus y would be 2. Y plus z is 1. Z minus x is 0 minus 1. And then we use this formula, where this is x, y, z, and we plug them into here, here, and here, and what we get is this. Similarly for the second, we take the image of it under t, what t does to it, sends it to 1, 1, 0 using this formula, and then we break this up using this into coordinates relative to the basis B1, and same thing for the third vector, the 0, 1, 1. I'll leave you to check. Now that we have all these calculations, we get the result, which is our matrix for the transformation t relative to B1. We get it from these numbers here, but notice that there is a transpose. Here I have 2, 0, minus 1 as a row. Here it's a column. 1, 0, 0, that's the second column. Don't forget to transpose. Don't just copy them as they are. Okay, so that's part 1. And now on to part 2.